So if you've followed my channel long enough, you'll know that I've really gotten into renewable energies, particularly solar, lately. And I have posted several videos on my setup, but I have made some changes since my last video I posted. I've been getting some questions about the different stuff that I have done. So, I've been really busy lately with the kids going back to school and the fall cleaning, getting out all the fall stuff out of storage and things like that, working on my car especially. Before it gets too cold. So I'm going to go ahead and run through this entire setup, and I'm going to do that because for those of you who may not have seen my previous video, I'll just kind of go over everything so that you have a really good idea of how I've got things set up. Now right now it's about 9 o'clock in the morning and it is extreme overcast right now. It's actually sprinkling a little bit out there, so I'm not getting much light, but I'm actually getting enough to where I'm actually generating some electricity to keep my battery charged. And this is an on-the-grid, off-the-grid setup. It was originally off-the-grid completely, and then I converted it to grid tie as well as off-the-grid. And I'll go over all that stuff, over the course of the video. But essentially, I have I have three 100-watt grape solar panels. I have two on the balcony, and I have one in the master bedroom. And my building, my apartment that I'm in, faces directly west. So in the summertime I'm able to get direct sunlight from about 1 o'clock until about 8:30, 9 o'clock or so, depending on conditions or whatever. And in the wintertime, as we approach winter, which we're right now into the fall, that sunlight is becoming less, which I'm okay with that. That's to be expected. So right now I'm getting about 6 hours of sunlight possible, and that's going to cut down even further to probably about 5.5 hours, kind of depending on different things. So obviously the summertime is the best time for electricity, generation from the sun. And wintertime is the worst. The sun isn't out as much, it doesn't go as high in the sky, etc., etc. So anyway, I'm going to go ahead and go over everything. You got three 100-watt solar panels tied into this, as well as a bicycle generator. And again, I'll go over everything for you. So you can see here, this is my enclosure box. This is where I keep all of my stuff. This is a 12 by 12 by 4 enclosure box, and it's just a standard electrical enclosure box. I've got the option for lock if I really wanted it, which I don't. I just use a screwdriver or whatever to keep it closed. And on the outside here you can see that I've got my digital voltmeter, which lights up blue so I can see it even at night. It draws very little power. It's about 30 milliamps of power, so I don't have to worry about the battery going dead at night with this thing running. On the other side I have an analog amp meter, and this allows me to see what the system is actually generating. Okay, I'll go into the details as far as the specifics of that later, but this is what I see basically when the panel's closed, so I know that everything's essentially working fine, which you can see here that it is. When it hits about 14.15, 14.20 around there, it goes into divert mode, so that's to protect the battery. 14.15. That protects the battery, and it's floating the battery right now, essentially speaking. The charge controller is. And of course I can see the amperage on here, and I've taken several videos of this so you can check those out. But let's go ahead and open this up. This here is the entire setup that I have here inside the enclosure box. And what you can see is I have two terminal distribution blocks right here. One of them is positive, one of them is negative. This is my ground, okay? And essentially I've got all of the electricity that's coming in going through the positive, and I have it jumped so it's all together, and it's generating, it's 12 volts total. I've got 12 volt panels. I've got a bicycle generator which generates more than 12 volts, but it's not that much more. And so everything coming into the system goes through this terminal block here, okay? From there, I've got it coming out to a single 8-gauge wire. And of course, all these I've crossed with 8-gauge. The only thing that's less than 8-gauge is the things that don't carry much current, such as the sense wires, the shunt wires to the ammeter, but everything else is wired in 8-gauge wire right now. So I've got a single 8-gauge wire running to the shunt. This is a 75 amp shunt. This allows me to see the amperage of everything that's coming into the system. Now before, I had this actually on the battery side of the charge controller. Now I've moved it down here so that I can see everything that's coming in, not only from the panels, but also the bicycle generator, and it allows me to also see what's going into the grid tie inverter. I'll get into the grid tie inverter later. So essentially everything that's coming into the system, I can monitor it here through the analog amp meter, okay? And so I've got the positive here, and this is positive here actually, and positive essentially, and it's wired into the analog, amp meter. From there, I have a single out 8 gauge running into this switch. Now, if you'll remember, if you've seen my video from the past, you'll know that I've used this 30 amp DC circuit breaker. Now, the main reason that I got this was for me to be able to manually turn on and off the systems, to be able to isolate it so that I could work on it, or for protection, or whatever the case may be. The problem that I noted before was that this is a 30 amp DC circuit breaker. The charge controller itself is a 25 amp, so this isn't going to protect the charge controller from damage if something were to happen. So essentially it was just an on-off switch for me, and unfortunately I couldn't find a 25 amp DC circuit breaker. They just don't make them. So that was kind of redundant to have this, but for me it was more peace of mind to be able to have something that was actually rated for DC amperage, okay, for a DC circuit, as opposed to what you have in your house where you have AC circuit breakers. So I've got this switch here, and this is a battery bank switch, and it's really nice. This is actually the small version, and it'll handle a constant load of 300 amps at 32 volts. So it's overkill for what I need, but this is actually the smallest one they had, and this is really high quality. It's a make before break. It handles all that amperage, and it's really nice. But I've got the electricity coming in to the switch, to the common, and that allows me to run it to either 1 or 2. 1 being the charge controller, 2 being the grid tie inverter, and I'll go into that grid tie inverter later. But this also doubles as an on-off switch. So now the system is off. The connection, the DC connection, is completely broke. So the only thing that's actually running still is actually the sense wires here that are still connected, monitoring the voltage, but everything else is cut off. So right now the solar panels are in open circuit right now, and so they're generating about, it's overcast right now, so not quite 22 volts, but so essentially everything's been opened up. So I could work on all this stuff and not have to worry about getting shocked or whatever. Plus, if I need to work on the panels or anything else like that, then I set this to off, and off I go basically. So right now there's no electricity going into the system. The circuit has been broke. And as you can see here, that's not going into divert. Go ahead and put this back to 1, which is my charge controller, and the battery voltage is starting to rise. So it is charging the battery now. Okay. And so I use this, essentially, what I was thinking is I actually had the grid tie inverter on the divert side of the charge controller. And I wasn't really comfortable with it after thinking about it, because number one, I wasn't getting good efficiency, because it would take 4 or 5 seconds for the grid tie inverter to catch up to the electricity that was coming from the divert. By that time, 3 or 4 seconds later, then it was coming out of divert and it was charging the battery. It was floating the battery. So I really wasn't getting a very good efficiency out of this. So I just decided that I was going to be able to manually switch it back and forth. So when I'm away at an extended period, let's say I'm gone from morning till night or whatever, I'll switch this over to grid tie inverter, let the inverter dump all the electricity back into the grid from the solar panels, and that way I don't have to worry about the battery being completely charged and just basically wasting electricity in divert, okay? That's essentially why I did this. Whereas before, I had the 2 panels on the balcony or whatever, this thing would get charged and it would just be floating the battery constantly on, off, on, off, on, off, on, off, and I'm not really comfortable with that. So when I'm away for an extended period of time, during the day or whatever, I just switch this over to grid tie, and let the grid tie inverter dump the electricity back into the grid. So I'm not wasting any electricity, okay? But anyway, back to the circuit. This one runs into this 8 gauge wire. which runs up to this 25 amp AGU fuse. This 25 amp fuse will protect this charge controller. If there's a spike in amperage or a short of some kind or whatever, this is going to protect the charge controller. It's going to break the circuit. So if I'm in the battery mode, then it's going to break it and protect this charge controller, because this charge controller is only rated for 25 amps, okay? So if it goes over 25 amps, it'll burn the charge controller up real fast. I think it can handle a peak of 50 amps for like a half a second or something before it completely ignites this this charge controller. So that's essentially what I did. Okay, so this 25 amp AGU fuse here protects this charge controller from damage. Okay, this is a flex charge 25 amp charge controller, 12 volts. They make them all different voltages from 12 to 48 and different amperages as well. And they have expansion setups where you can actually use this charge controller, and then they have like 150 amp slave that you hook up to it, so this controls an actuator that will handle more electricity and so on and so forth. It's expandable, which is really nice. But what's really great about this charge controller is the fact that it's like 99.5 or better efficient. And I know it, and you can tell from my previous videos that it really is that efficient, because I watched the amperage and I can see that, you know, with one panel 5.56 amps, I'm getting pretty much 5.5 amps from the charge controller to the battery. This thing is super efficient. It doesn't have all the bells and whistles that a lot of other ones do, like voltmeters and all the buttons and things like that, but that's not the point. The point is that this charge controller takes everything, basically everything from your either panels or wind generator, whatever, and will convert it to the voltage necessary to charge the battery. So you're losing basically no electricity with this charge controller. And you know, I had a lot of questions when I was going to get this, because the manufacturer of the battery, the AGM battery that I had, said I had to charge it this way. They say they charge it a certain way. So you know, they've got this elaborate diagram that they've rolled out to show you that you know, their system is actually better at charging all batteries. All you do is you set the voltage to what you want the battery to be, and off it goes. It's as simple as that. So you can see right here that it's going back and forth between divert and charge. But I don't have anything on the divert, which is fine. It just basically opens the circuit. But if I had something connected to divert, then it would take the electricity, run it through the divert. Why you would want to have something hooked up to the divert? Well, that depends on your situation. If you have wind generators, they're spinning really, really fast. They have to have a load on them. So your batteries get fully charged. This charge controller goes into divert. That's immediately going to remove the resistance of the battery, and it's going to cause your wind generator to just spin freely, and it could actually damage it. So what they do is they have these diverts on here, and you hook it up to like a coil of wire or some kind of resistor or whatever else to keep the load on the wind generator, so it's constantly under load. That's the whole point. You want to keep it under load so it doesn't spin freely and, you know, end up destroying itself. So anyway, that's what the divert is. This is the battery wire. This is essentially the charging wire. This is an 8-gauge wire. This runs directly to the positive side of the battery. This here is your battery sense wires, positive and negative. I have a 2 amp fuse, just a standard automotive fuse on here, just to protect, just in case there's some kind of a short or whatever. But these are battery sense wires. They're hooked directly to the battery, which is required for this charge controller, so that it knows exactly what the voltage is of the battery. That's all important, so it doesn't overcharge the battery. Okay, so these run straight to the battery. Okay, from there you'll see that I've got this negative terminal block here, which actually isn't connected to the charge controller, but this is the next step in the whole system. But what I have here is the negative side of the battery is right there. So this is the negative terminal of the battery, runs to here, and I've got this jumped across to this entire block. This is the negative side of the solar panels, okay, and the negative side of the bicycle generator. So essentially it's the ground for the entire system. Okay, and so this is essentially the entire enclosure box. So pretty simple, pretty efficient. I know some of it looks a little bit ugly. You know, I haven't shrink wrapped or shrink tubed this yet, just haven't got around to it. But this is the whole setup. It's pretty small. You know, I've seen some really elaborate setups, and you know, there's a guy who has like 24 batteries or something on one of his setups. I mean, some of this stuff is crazy. I just have a single battery and 3 panels, but So anyway, this is the entire setup. This is inside the enclosure box. It's really nice. It's compact. I consider it pretty neat. I did a lot of research to make sure everything was going to work fine. So there you have it. That's the actual enclosure box. Okay. Now I'm going to actually go over the other parts of the setup, and I'm going to switch over right now. Okay, so here's the lower end of my setup, and underneath here I have a VMAX tank battery. It's an SLR 125. It's 12 volts, 125 amp hours essentially. It is a deep cycle battery, and it's probably one of the best batteries on the market for solar power, and they're made specifically for off-grid setups. And it's a really nice battery. This is a custom battery caddy that I made. I put it on wheels so that I could actually roll this around, and I have enough wire here to be able to roll it around a little bit if I need to, basically for emergency purposes, so that I can reach my refrigerator, whatever else I may need, without having to run 30-foot extension cord or anything else like that. But so this is my battery caddy. It's just made out of wood and some caster wheels. But so it's a really nice battery. This is a Royal Power 1000 watt, 2000 watt peak pure sine wave inverter. It converts 12 volts to 115 volts, and it closely mimics the actual outlet electricity, so I can run my sensitive equipment like my computers and so on like that without having to worry about possible damage or them working improperly. So this is a really nice inverter. I paid almost $300 for it. It is probably one of the best on the market. I had absolutely no problems with it. It works really well. It reads the battery voltage, as well as how much electricity is actually being used from it. But so yeah, really nice, and it's got the 3 plugs on it, which I really like. Most of these just have 2 plugs. Okay, so this right here is my grid tie inverter, meant specifically for solar panels. I don't run the bicycle generator with this. I run just the solar panels. It'll actually handle up to 620 watts input with a 500 watt output setup. And basically what it does is it just runs straight to the grid. So my solar panels are actually transferring electricity from the setup to the grid. So it actually will spin my meter backwards. As funny as that sounds, I have a couple videos on this grid tie inverter, so you can check those out. I'll leave a link in the description. But essentially, this allows me to not be able, not waste the solar panels on trickle charging the battery or floating the battery. So when I'm away, then I have it running. Now it's off right now, but if it were on, you'd see a green light. There's unfortunately not enough electricity generating from the panels right now because it's so cloudy out. So there's no point in having it on, because it's just going to go into fault. It's going to keep on trying to track and then go into fault. So I have it off, and it's floating the battery right now. But on a side note, I don't have the inverter running when I'm home, and it's generating enough electricity for me to run this inverter, okay? And I'll explain myself. Let's say that I'm generating 100 watts of electricity from my whole setup, okay? And I've got my computer running. I will run it off of this inverter. The reason is because between the charge controller and this inverter, the conversion is about 95%. It's greater than 90, but I'm finding it to be around 95%, okay? So 95% of the electricity from the panels is going to whatever item I'm powering, okay? The grid tie inverter, on the other hand, is only about 75% efficient. So if I were sitting here watching movies or on the computer or whatever, and I just have the grid tie inverter running, I'm losing about a quarter of the electricity that I'm generating. So it's better to have the inverter from the battery be able to power my various objects that it is to have the grid tie inverter. The grid tie inverter is basically there for a backup for me, so I don't lose any electricity if I'm not home, or I'm not running anything or whatever. That's the whole point. So just so we clear that up, alright? So that's essentially the bottom end of the system. I only have one battery. I am going to expand to 2 batteries and then eventually to 4 batteries. But it's an expensive way to save money on your electric bill, so that's if that's what you're thinking. So I've got more videos on that, so check that out. But so this is my entire setup here at this end, and I'm going to go ahead and show you what my bicycle generator looks like and how. Okay, here's the bicycle generator. I have another video on this bicycle generator, so you can check that out. But essentially speaking, I've got a DC motor here that I spin with this belt and wheel. I basically just get on the bike and bike. Right now the bike's in the air, but I do this about 4 times a week, and I've got a blocking diode here to make sure that the battery doesn't cause this to spin, and I've got its own 25 amp AGU fuse on that end to make sure that I don't put any more than 25 amps into the system, which I never have, obviously. This particular motor is actually rated up to 280 watts and up to about 28-30 volts, but the charge controller will pull that down to what's needed, so it works out really, really well. But this is actually good for losing weight, and it's good emergency power, because let's say that I lose electricity at night. I won't be able to run my fridge for all night long just off of one battery. So to be able to hop on this bike and be able to essentially generate the electricity required to run the fridge is really cool. So this is like an emergency backup, but I also use it to lose weight and keep the batteries charged. When the wife's on the computer or something like that, I'll hop on for a half hour, 45 minutes to help out. So it's pretty cool. It's a nice little setup. I've got a video on it, so you can check that out. But yeah, so that's my entire system, and then I have one solar panel in the master bedroom, which I have tied into this whole thing. So alright, that's it. There's my solar panels out on the balcony. I got a video on those. I've got everything basically on YouTube. You just check it out. But the main purpose of this video was so that you could see what I've changed recently with the whole setup, mainly adding that switch. So alright guys, if you have any questions, let me know for sure. But I've essentially taken an apartment complex and I've added solar, and it's just something that you don't see basically anywhere, and so it's pretty fascinating that you can do it, and hopefully this encourages some of you out there to do the same thing. I do have to add security to this thing. I'm going to add a camera and so on, because I'm just not sure about somebody possibly taking these. Although it would be difficult, it's not going to be impossible. And a determined thief, if they really want to be able to cut through a thick chain or something like that, then I guess they can have them. But anyway, I'll get some videos of that later on when I get it figured out. So, if you got any questions, let me know. I'll catch you guys later.